transformer in the input have a 120, hot and neutral, and the ground, the input. In the output, they have different options. Between this and this, 60 volts. Between this and this, 40 volts. Between this and this, 20 volts. What type of transformer is this? A step down. Because I have 120 here, 60, 40, and 20. You understand? In the output. Nice, no? Can I get a similar transformer step up? Yes. But let me explain something. When you have 120 volts in the input, and in the output in this configuration, no 120, 40 volts. I have 40 here, and 120 here. In what side I have more power? In this one, in the primary coil, or here in the secondary coil? In which one I have more power? Excuse me? The power is the same. That's the secret. The power is the same. And we are going to play with the ohm law. You remember what is the formula for power? Power is equal to voltage times intensity. Okay. Let me check if I have this voltage in the, how much is the amps? And we are going to play with that. And this is the secret to calculate a transformer. In this particular example, I have, this is the primary, and this is the secondary. In the primary, I have it's supposed that the power in the primary should be equal to the power in the secondary. Yes or no? Okay. How much is the power in the primary? Is the voltage in the primary times the intensity. Should be equal to the voltage in the secondary times the intensity in the secondary. In this particular example, how much is the voltage in the primary? 120 volts times the intensity, 10 amps. Should be equal in the secondary. The power should be equal. In the secondary, I know the voltage. Yeah, because I say that I have 40 here. No, I have 40 volts. Okay, I have 40 volts here. And how much is the intensity? This is the question, the $1 million question. It's simple. Intensity in the secondary is equal to 120 times 10 divided by 40. How much is that, please, secretaries? It's 30 amps, no? No? Okay, look at this. It's interesting. If I have 120 volts in the primary, if the voltage in the secondary is lower, what happens with the intensity? The intensity here is 10. What happens if I have less voltage in the secondary? To compensate the power, the intensity goes up to keep the equilibrium. And this is the magic formula. For that reason, you can use that formula. Look, that formula. Voltage in the primary times intensity in the primary is equal voltage in the secondary times intensity in the secondary. Or you can put the formula in this way. Divided by the voltage in the secondary is equal to the intensity in the secondary divided by intensity in the primary. You see? This is the magic formula. And with that formula and using simple calculations, you can find the intensity or the voltage. And you can add it other important element. The voltage is directly related with the number of turns in both sides. And this is the complete formula. I have the number of turns in the primary divided by the number of turns in the secondary is equal to this and is equal to this. This is the magic formula. And with that magic formula, you can calculate the voltage or the intensity. If you have the information about the primary, you can calculate the information in the secondary or vice versa. Everybody follow me? For example, in this particular case, how much should be the amount of turns in the secondary? If I have 100 turns, 100 loops, Okay, I am going to use the formula. How much is the voltage in the primary? 120. The voltage in the secondary? 40. Should be equal to the number of coils in the primary, 100, divided by the number of coils in the secondary. Number of coils in the secondary is 100 times 40 divided by 120. How much is that? 100 divided by 12? 400 divided by 12?
33.33.
32? Okay, 32 coils in the secondary. Nice, no, guys? You enjoyed the explanation? It's clear? You need simple mathematics. You need the second grade of elementary. That's it. That's it. Simple. Don't forget, the power stay constant. Later, we are going to learn the procedure to calculate the capacity of the battery bank that I need in the inverter in this side in order to produce in the second side 4,000 watts or 5,000 watts. How many batteries I need here to produce that? It's simple because the power here should be exactly the same power here in the output. With that idea, it's easy to calculate the capacity of the battery bank.